Good evening, ma'am.
Good evening, sir. You can start now, sir.
Ma'am, we made Dhanlakshmi the host.
Dhanlakshmi, make sir as a host, ma'am.
She's
Yes,
made.
ma'am, made, ma'am. Good evening, sir.
This is 11th standard topic. Basic concepts. Continuation of the topic. The mole concept, very interesting concept, very interesting topic. We have already introduced what is mole in the previous classes. We'll continue with that. This pictorial representation, you can go through that a little later. We will try to understand what is mole. Now, atomic mass of carbon is 12. The stable isotope of carbon is 12. So if we take 12 grams of carbon, this 12 grams of carbon will contain 6.023 into 23 carbon atoms. Carbon atoms. Now, if we take carbon dioxide, the molecular mass of carbon dioxide is 12. Carbon is 12 plus oxygen 16 into 2, that is 44. So 44 grams of carbon dioxide also will contain 6.023 into 10 to the power 23 carbon dioxide molecules. Now, if you take sodium hydroxide, in which the atomic mass of sodium is 23, oxygen is 16, and hydrogen is 1. The molecular mass is 40. So 40 grams of sodium hydroxide also contains 6.023 into 10 power 23 sodium hydroxide molecules. Now, if we take any other component, maybe we can take an element for that matter. We'll take sodium as such, only the sodium metal. If we take the atomic mass of sodium is 23. 23 grams of sodium, if we take, it also contains 6.023 into 10 to the power 23 sodium atoms. Now, what is a mole? Now, this 6.023 into 10 power 23, this number is called as Avogadro's number. Avogadro's number. Now, what is mole? How do we define mole? Weight of any substance. Weight of a substance containing Avogadro's number of particles is called as a mole. Now, particles, when we say, it can refer to atom, it can refer to molecule, it can refer to ion, anything. So what is a mole now? Mole is defined as amount of substance, weight of a substance which contains Avogadro's number of atoms, molecules, or ions is called a mole. Now, if we take 12 grams of carbon, the atomic mass of carbon is 12 grams. So we take exactly 12 grams of carbon and find out how many number of carbon atoms are present. It contains 6.023 in 10 power 23. Therefore, 12 grams of carbon is called as 1 mole. Now, if we take 44 grams of carbon dioxide, this 44 grams of carbon dioxide, if you find out how many molecules of carbon dioxide is present, it contains 6.023 10 power 23 carbon dioxide molecule. That means 44 grams of carbon dioxide corresponds to 1 mole. Now, sodium hydroxide, 40 grams of sodium hydroxide contain 6.023 10 power 23 sodium hydroxide molecule. Therefore, 40 grams of sodium hydroxide will be called as 1 mole of sodium hydroxide. Now, 23 grams of sodium contains 6.023 10 power 23 sodium atom. Therefore, 23 grams of sodium also will be called as a mole. See, this mole is called as a chemist's dozen. Chemist dozen. Now, why do we call this as a chemist dozen? Because we cannot isolate an atom or we cannot isolate a molecule, or we cannot isolate an ion and perform the experiment. It is not possible for us to separate or isolate an atom, ion, or molecule and perform an experiment. Therefore, we have to take atom, molecule, or ions in terms of groups. That group is named as what? A mole, and it is called as a chemist dozen. Do not confirm when we do not understand that when you say dozen, it is 12. No, it is only a representation for a mole. Mole is termed as chemist dozen. Now, coming to the next slide. Now, Avogadro's number, I told you there's no point in talking about Avogadro's number again. This is 10 to 6.023 into 10 to the power 23. Avogadro's number is defined as number of atoms present in 1 gram atom of an element, or the number of molecules present in 1 gram molecule. See here, this is an atom. Carbon is an atom. 1 gram atom is 12 grams. 12 grams of carbon contains 6.023 in 10 power 23 carbon atoms. Therefore, 12 grams of carbon is called as 1 mole. Now, if you take carbon dioxide, it is 44 molar mass, molecular weight. 44 grams of carbon dioxide contains Avogadro's number. Therefore, it is called as 1 mole. These units can be atoms, molecules, ions, electrons, or anything else. 1 mole of hydrogen means 6.023 in 10 power 23 hydrogen atom. So hydrogen atomic mass is 1. Now, 1 gram of hydrogen contains 6.023 into 10 power 23 hydrogen atoms. Therefore, 1 gram of hydrogen will also be called as 1 mole. But we all should know that hydrogen do not exist as atoms. It exists as a molecule. So when it exists as a molecule, the molecular mass of hydrogen will be 2 grams. 2 grams of hydrogen contains 6.023 into 10 power 23 hydrogen molecules. Therefore, 2 grams of hydrogen will also be called as 1 mole. So, mole is defined as amount or weight of a chemical substance which contains Avogadro's number of particles. Now, 1 mole of hydrogen molecule is 6.023 in 10 power hydrogen molecule. 1 mole of potassium ions is 6.023 in 10 power 23 potassium ions. 1 mole of electron is 6.023 in 10 power 23 electrons. We have learned all this I have explained. It is only a pictorial representation. What is 1 mole? 1 mole corresponds to 6.023 in 10 power 23 particles. If it is in terms of volume, now we learned in the previous classes, carbon dioxide, the molecular mass is 44 grams. If you take it in gram, it's gram molecular mass. Now, 44 grams of carbon dioxide, if you blow it in a balloon, it will occupy 22.4 liters at STP. So this 22.4 liters is called as molar volume. So volume occupied by 1 mole of a gas is called as molar volume. So in terms of volumes, 22.4 liters, 1 mole of a gas will occupy 22.4 liters of gas at STP, normal temperature and pressure, or STP. Now, 1 mole of oxygen atomic mass is 16. So 16 grams of oxygen contains 6.023 to 10 power 23 oxygen atoms. Now, I should tell you around 15 to 20 questions you will get it from first PUC for your CET. All right. So we need to learn this MCQs also. We'll be learning as we learn the subject. Since a lot of mathematical concepts are involved, I'm taking some time to explain this. Now, 1 mole in terms of mass. If you take carbon and sodium, they are elements. So when they are elements, we have to take their atomic mass. Carbon atomic mass is 12. 12 grams of carbon corresponds to 1 mole. Atomic mass of sodium is 23. So 23 grams of carbon and sodium also corresponds to 1 mole. If we are talking about a molecule, water is a molecule. The molecular mass of water is 18. 18 grams of water contains 6.023 into 10 to the power 23 water molecules. Therefore, 18 grams of water is called as 1 mole. So likewise, I spoke about carbon dioxide. Here it's there. If you take gram molecular weight, formula weight of substances like sodium chloride, it's a salt. Sodium atomic mass is 23, chlorine atomic mass is 35.5. So it will be 58.5. This 58.5 grams of sodium chloride contains 6.023 to 10 power 23 sodium chloride molecules. Therefore, 58.5 grams of sodium chloride will be called as a mole. Likewise, calcium carbonate, if you take, atomic mass of calcium is 40, carbon is 12, oxygen 16 to 3, it's 48. The molecular mass is 100. So 100 grams of calcium carbonate also contains Avogadro's number of calcium carbonate molecules. Therefore, that also corresponds to 1 mole. In terms of elements, atomic mass. In terms of molecules, it is molecular mass. And in terms of compounds, we need to take formula mass. So the sodium chloride, 58.5 grams. It contains Avogadro's number. Therefore, it is called as 1 mole. So I hope that you followed. Are you following?
Yes, sir.
Yeah. Now, Avogadro number, how much does 1 mole weigh? That we cannot have a specific answer for that. Why we cannot have a specific answer for that is because each atom has different atomic mass, each molecule has different molecular mass. Therefore, for this question, how much of one molecule weigh? The answer for that, it depends on the nature of particles, units. The mass of 1 mole of any atom of an element is exactly equal to the atomic mass in grams. See, clearly they are mentioning mass of 1 mole. Mass of 1 mole of atom of any element will exactly be equal to its gram atomic mass. Atomic weight or gram atomic mass. Now, what does it mean? 6.023 into 10 power 23 carbon atoms. It will exactly weigh 12 grams of the exactly weight 12 grams. Likewise, if you take 6.023 into 10 power 23 sodium atoms, it will exactly weigh 23 grams of sodium because the atomic mass of sodium is 23. That is what it means. It depends on the nature of particles. So we cannot generalize how much does 1 mole weigh. It depends on the nature of the particles. So if you take hydrogen gas, 6.023 into 10 power 23 hydrogen molecules, it will weigh exactly 2 grams. See, the numbers are same here. Numbers are same, but the weights are varying because it depends on the nature of the particles. Now, the atomic mass of aluminum is 27. One atomic unit is equal to 1.66 into 10 to the power 23. How do we find this? Now, we know we will generalize this. This looks a little complex. We'll come to this a little later. Now, we know that atomic weight of aluminum, they've given 27. So we also know that 27 grams of aluminum contains 6.023 into 10 power 23 aluminum atoms. So if I ask you, what is the weight of one atom of aluminum? So one mass of one atom of aluminum will be a cross multiplication to find that. That will be 27 into 1 divided by 6.023 into 10 power 23. This will give you 1.66 into 10 to the power minus 27 grams. This value. Now we are going to generalize. Now, what's the mass of one atom? So mass of one atom is given by the formula atomic mass by Avogadro's number. When you take atomic mass, see, this 27 into 1 is 27. 27 is nothing but the atomic mass of aluminum. So when atomic mass divided by Avogadro's number is 6.023 in 10 power 23. That will give you mass of a single atom, mass of one atom. So if that's the case, this formula you should remember. What will be the mass of one molecule? What will be the mass of one molecule? Anybody? What will be the mass of one molecule? It will be molecular mass divided by Avogadro's number. See, for the competitive exams, you will not be allowed to use calculators. So you need to practice a lot of problems. If you are able to practice a lot of problems, only then you will be able to solve the mathematics. If you're just listening and if you are not putting in effort, it's a bit difficult. So therefore, practice a lot of addition, subtraction, multiplication, all that. When you solve problems, you will get to know. So mass of one atom is given by the formula atomic mass by Avogadro's number. Mass of one molecule is given by the formula molecular mass by Avogadro's number. Similarly, you can see the mass of 6.023 in 10 power 23 molecules, which is 1 mole of a substance, is equal to its molecular mass. As we learned here, where is it? As we learned here, it's dependent on nature. Mass of 1 mole of atoms of any element is exactly equal to its atomic mass. Here we are learning mass of 6.023 in 10 power 23 molecules or 1 mole of a substance is equal to its molecular mass. I just told you carbon dioxide. So 6.023 into 10 power 23 carbon dioxide molecules, exactly it will weigh 44 grams. So 6.023 in 10 power 23 molecules of carbon dioxide is nothing but what? 1 mole. 1 mole will weigh 44 grams. Here they've taken water as an example, H2O. Water is a molecule. So the molecular mass of water is 2 into 1 plus 18. Atomic mass of hydrogen is 1. 1 into 2 is 2. 18 is that? 16. This is 16. So the molecular mass is 18. So 18 grams of water is nothing but 1 mole. This 18 grams of water, 1 mole, which contains 6.023 into 10 power 23 water molecules. Water molecules. Now, how do you find the molecular mass of water? Weight of or mass of one water molecule. How do you find? So mass of one water molecule is given by the formula molecular weight by Avogadro's number. So molecular mass is 18. Avogadro's number is 6.023 in 10 power 23. So if you divide this, you will get again 1.66 into 10 power, not 1.66. This is wrong. So you will get around 3 point something you will get. You do the simplification. So mass of one water molecule is molecular weight by Avogadro's number. Now, some of the questions we will learn. A mole of any substance is related to number of particles, mass of the substance, volume of a gaseous substance. The answer should be all the above. All the above. 1 mole of any substance is related to number of particles. So if it contains 6.023 in 10 power 23, it is called as 1 mole. It is also corresponding to molecular mass of the substance, atomic mass, gram atomic mass or gram molecular mass. And if it contains 22.4 liters at STP, this also is called as what? 1 mole. So the answer should be all the above. I hope that you're following. Are you there?
Yes, sir.
Yes, sir.
The next, where's the card? Where's that? It's not working. Right. Now, mole particle relationship. Now, 1 mole is collection of Avogadro's number of particles. This is not 1023, it is 10 power 23. So this is scientific notation. All that we have learned, scientific notation, significant figures, all that we have learned. So a mole is a collection of, 1 minute. 1 minute. So this is again, we're talking about mole. Mole is a collection of 6.023 10 power 23 particles. Particles refers to atoms or ions or molecules. So Avogadro's number, we understood that it contains this value. This number is called as Avogadro's number. There's no point in learning this again. This is 10 power 23. Please understand this 10 power 23, 10 power 23. You can read this slide. We have learned already this one. Next, this is again 10 power 23. Typo. This is also 10 power 23, 10 power 23. Now 6.023 into 10 power 23 atoms of sodium constitute 1 mole of sodium atoms. So 6.023 in 10 power 23 molecules of oxygen constitute of 1 mole of oxygen molecules. 6.023 in 10 power 23 electrons constitute of 1 mole of electron. So number of moles also can be calculated by another formula. So how do we calculate number of moles? Generally, we used to calculate number of moles by the formula weight in grams by molecular mass. This is the formula what we used in order to calculate the number of moles. Now, based on the number of particles, we also can calculate number of moles. Number of moles can be calculated by the formula number of particles by Avogadro's number. Number of particles by Avogadro's number. Now, let us see. Calculate the number. I want someone to answer me this question. Calculate the number of moles of 6.023 into 10 power 22 sodium atoms. What will be the number of moles of 6.02 to 10 power 23 sodium atoms? Anyone? 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 The formula is here. Number of particles given as 6.023 into 10 power 22. What's the Avogadro's number? 6.023 into 10 power 23. So what happens? This will get cancelled. And if it goes to numerator, it becomes minus. So 10 to the power minus 1. 22 and 22 will get cancelled. So you'll have 10 to the power 1 in the denominator. If it goes to numerator, 10 to the power minus 1. 10 to the power minus 1 is nothing but 0.1 moles. It's a simple question. These kind of questions only will be asked, and you should know. Now, this is what we've written, mole and particle relationship. So this is mole and particle relationship. Number of moles is calculated by the formula number of particles by Avogadro's number. Likewise, the next we're going to learn is mole weight relationship. This is known. How do we calculate number of moles? This has been learning from long time. In second PU, we also have learned. So mole concepts in the solution chapter you would have learned. Number of moles is given by the formula weight in grams by molecular mass. So they're given mass of substance in grams by molecular mass. So what does 1 mole of sodium weigh? 1 mole of sodium weighs 23 grams. So 23 divided by sodium is an atom. So you should take atomic mass of sodium, that is 1. Now calcium carbonate molecular mass is 100. So what will be if I say 50 grams of calcium carbonate? What is the number of moles? What is the number of moles? What will be the number of moles? Tell me. It will be 50 divided by molecular mass is 100.
Molecular
See
mass.
the 100. It will be what? 0.5 moles. So this is simple. This is simple. We'll learn. Now next is volume mass mole volume relation. This also we have learned. 1 mole of any gas at STP occupies 22.4 liter. That's called as molar volume. So 1 mole of a gas occupies 22.4 liters. If we say 11.2 liters, what will be the number of moles? It will be 1 into 11.2 divided by 22.4. It's cross multiplication. It will be again 0.5 moles. You can have different volumes. I've just taken 11.2 for our understanding. So what's the formula to calculate number of moles in terms of volumes? Volume of the gas in liters at STP divided by 22.4. What is this 22.4? This 22.4 is called as molar volume. See here, the same formula. Volume of the gas given is 11.2 liters. How do I find the number of moles? 11.2 divided by molar volume. So volume of gas at STP divided by molar volume. If at all they give you volume in ml or centimeter cube, now you take volume also in centimeter cube. 22.4 liters is 22,400 centimeter cube. Because we know that 1 liter is 1,000 centimeter cube. You can take this as 22,400 ml or centimeter cube. You should remember a lot of formulas we are learning. Please look at this. Look at this, and then we'll continue. Molecules. Formula: weight in grams by molecular mass. Formula sheet for calculating the number of moles. For atoms, which is weight in grams divided by atomic mass. For gases, volume at STP divided by standard volume. Standard volume is 22.4 liters. For any particle, number of particles divided by Avogadro's number. Moles of A in AXBY. It is X. This is where is that? Where is that link? This color, yeah. So this is not appropriate. We will learn. And for a gas at standard pressure, temperature, and volume, this is ideal gas equation. PV is equal to nRT. So number of moles can be calculated by the formula RT by PV. So N stands for number of moles. This is based on ideal gas equation. And the value for R in terms of atmospheres, it is 0.0821. So R is a universal gas constant. Do not consider to be 8.314 joules per Kelvin per mole. It is in terms of energy. In terms of atmosphere, R is the value 0.0821. Atmosphere per mole per Kelvin. This formula you should remember. Standard temperature and pressure. What do you mean by standard temperature and pressure? 0 degrees Celsius and 1 atmospheric pressure is called the standard temperature and pressure. 0 degree temperature always has to be taken in Kelvin scale. So 0 degrees Celsius is 273 Kelvin. 273 Kelvin. Next, what we have is formula weight. Formula weight of a substance is the total mass of all the atoms present in the chemical formula of a substance. If this formula weight is same as molar mass. Now, for an example, now if you take NaCl, formula weight of a substance, total mass of all atoms. So what's the mass of atom? Sodium, 23. What's the mass of chlorine? 35.5. So it'll be 58.5. So 58.5 is the formula weight. And molar mass is also what? 58.5. This is 58.5 contains Avogadro's number. That's 1 mole. So therefore, it will be also called as molar mass. See, formula weight also can be understood this way. Formula weight of a substance, total mass of all atoms present in a chemical formula. It is same as molecular mass. Oh, don't confuse yourself. It is same as molecular mass. Therefore, molar mass is equal to atomic mass or molecular mass expressed in grams. Depends on whether the substance contains atoms or molecules. So if you're talking about atom, we express it in gram atomic mass. And if the molecule is representing in molecules, we express in terms of molecular mass. This is same again. It is 10 power 23. 1 mole of atom is equal to, it contains 6.023 10 power 23 atoms. 6.023 10 power 23 atom will weigh its gram atomic weight. If it is a gas, it will occupy 22.4 liter at STP. The relation between mole number atomic weight of molecular mass, and also volume. So all this relation. So many formulas, what we learned in the previous slides, we are summarizing it here. So 1 mole of atom, if it is a molecule, so it will be 6.023 in 10 power 23 molecules, and it will be molecular weight, and this will be 22.4 liter. See, this 22.4 liter at STP, it's applicable only for gas. Solids will not, or liquids will not occupy the volume. So 1 mole of helium, helium is a gas. So helium atomic mass is 4. Helium is a monoatomic gas. Helium is a monoatomic gas. Why? Because helium is considered to be a noble gas. So it does not exist in a combined state. It exists in free state. So atomic mass of helium is 4. So 4 grams of helium contains 6.023 into 10 to the power 23 helium atoms. Therefore, this 26.4 grams of helium will be called as 1 mole. And this 1 mole will occupy 22.4 liters of volume at STP. So this is any gas you can consider. Since we are talking about helium, represented as helium, so I'm teaching. 1 mole of a molecule contains 6.023 in 10 power 23 molecules. That's equal to gram molecular mass. Now, for an example, carbon dioxide. Carbon dioxide is a molecule. So molecular mass of carbon dioxide is 44. So 44 grams of carbon dioxide contains 6.023 into 10 to the power 23 carbon dioxide molecules. This 6.0 into 10 power 23 molecules of carbon dioxide is corresponding to 1 mole. So 1 mole will occupy 22.4 liters at STP. Am I fast or you're able to follow? Nobody's answering. This formula you need to calculate. I will tell you only the procedures how to work these formulas. You should work and find out the answers. So I will not be in a position to deal with this because mathematics, I don't have a calculator also with me now. Mass of, in exam for you, they won't allow you to use the calculator. So you please practice at home. Mass of one atom of an element X is, so they have given mass of one atom is 1.66 into 10 power 26 grams they're given. So they're asking, therefore, what we're supposed to find is number of atoms in 1 gram of element. So they're asking you to find number of atoms in 1 gram of element. So this is what we're supposed to find. So I told you mass of one atom is calculated by the formula atomic mass by Avogadro's number. Since they have given mass of one atom, now mass of one atom 1.66 into 10 power 26 grams they will give. That will be equal to atomic mass by Avogadro's number 6.023 in 10 power 23. So what will be the atomic mass? Atomic mass will be 1.66 into 10 power minus 26 into 6.023 into 10 power 23. I think this simplification you will. And we will mark this as A. We will mark this as A, atomic mass as A. This is not the answer. They're asking what is the mass of 1 gram of element. Now they're asking number of atoms in 1 gram of an element. So we know that A contains, A is the atomic mass. A contains 6.023 into 10 power 23 atoms. A grams it is. A grams contains. A grams contains. So 1 gram contain how much? It will be 6.023 into 10 power 23 divided by A. Divided by A. So this is what is the formula. You check and tell the answer in the next class. You should find out what is A and divide 6.023 in 10 power 23 by A. Then you will get one of the answer. You find out and let me know. Or you work it out so that you will gain confidence. Are you following?
Yes, sir.
The next question, number of molecules in this is what? 16 grams of what? I don't know. 16 grams of, I cannot even exit this one. If I exit, I will not. This is always a problem. How do I? What does this mean? Sorry. What does this mean? So let's see this out. Oh, 1 minute. Yeah, now I think. So number of, I don't know. The number of molecules in 16 grams of methane. 16 gram methane, the molecular formula, what was the methane molecular formula is CH4. The molecular weight of methane is 12 is carbon, hydrogen 1 into 4, it is 16. So 16 grams of methane is called as 1 mole. So 1 mole will contain 6.023 into 10 power 23 methane molecules. So you need not have to work this. If you could find the molecular mass, we understand it is 1 mole. So 1 mole will contain 6.023 10 power 23 methane molecules. Methane molecule. This 6.023 10 power 23 methane molecule is nothing but Avogadro's number. So number of molecules in 16 grams of methane is Avogadro's number. The next one, the mass of 112 centimeter cube of oxygen. Please pay attention. Mass of 112 centimeter cube of oxygen at STP. Oxygen they're asking. What is the mass of 112 centimeter cube of oxygen? Can I say 22,400 centimeter cube of oxygen weighs 32 grams? Because oxygen is a molecule. So 16 plus 16 is 32. So 32 grams of oxygen is nothing but 1 mole. So 1 mole will occupy 22,400 centimeter cube. That's mass, a mole and volume relation. Now they are asking you the question, 112 centimeter cube of oxygen, what will be the mass they're asking? So it will be 112 into 32 divided by 22,400. You can simplify this. If you simplify, I don't have the, let me check. I will tell 1 minute. So it is 112 into 32 divided by 22400. So it will be 0.016. Answer what we'll get is 0.16, not 0.16. So grams. So the answer for this question is option A. I hope you're following. This you will get only 1 minute to work these questions in CET or competitive exams. Now a flask AB of equal size. A flask AB of equal size contains 2 grams of hydrogen and 2 grams of nitrogen, respectively at the same temperature. The number of molecules in flask A is same as that of B, less than the in the flask of B, greater than those of in flask B, exactly double. See, 2 grams of hydrogen is equal to how many moles? So number of moles will be what? 2 divided by 2. Molecular mass of hydrogen is 2, so it's 1 mole. So 2 grams of nitrogen will be how much? So number of moles. What's the molecular mass of nitrogen? What is the molecular mass of nitrogen? What is the molecular mass of nitrogen? The molecular mass of nitrogen is 28. So 2 divided by 28. What will be 2 divided by 28? Two divided by 28 will be equal to 0.071. See here, number of mole is 1 for hydrogen. So here it is 0.01, 0.071. So that means number of moles of nitrogen is very less. That means hydrogen will have more number of molecules. Here you will have 6.023 into 10 power 23. Here it will be much lesser. We can calculate, but not necessarily. The option they've given is the number of molecules in flask A is greater than that of B, because this is 1 mole and this is 0.071 mole. So therefore, the number of molecules will be greater for hydrogen in flask A. Largest number of atoms. How do you find which of the following has largest number of atoms? In order to find the number of largest number of atoms, what we're supposed to do is we're supposed to find the number of moles. Now, first one, A, 0.5 gram atom of copper. Atomic mass of copper is 63.5. Atomic mass of copper is 63.5. Please remember. In the first case, what will be the number of moles? Number of moles will be equal to 0.5 divided by 63.5. So 0.5 divided by 63.5. So it will be 0.0078 moles. Option B, 0.635 gram of copper. So it will be 0.635 divided by 63.5. So it will be 0.635 divided by 63.5. That is equal to 0.01. Now the next one, largest number of atoms. So see the third option, they have changed it. 0.25 moles they were given. So third option is 0.25 moles, 0.25 moles. We'll keep it like this. The fourth option, they've given 1 gram of copper. So number of moles is equal to what? 1 divided by 63.5. Sorry, 1 divided by 63.5 is equal to 0.0157. 0.01. That means 0.25 is greater compared to all the other. Therefore, the number of molecules will have a large number of atoms will be, largest number of atoms will be for 0.25 moles. Hence, the answer is option C. The next question. 1 liter of gas at pressure of 10 power minus 6 millimeters of mercury at 25 degrees Celsius. How many molecules are present in the vessel? How many molecules are present in the vessel? 1 liter of a gas at a pressure of 10 to the power 6 millimeters of mercury at 25 degrees Celsius. So this problem, I think so the data in the question is not complete. 1 liter of a gas at pressure 10 to the power 6 millimeters of mercury at 25 degrees. How many molecules are present? The data is not complete. They have not given the name of the gas also. So it will be difficult to calculate the number of particles. So we'll see. This is not clear. Now, some of the home exercise you have, you can just go through these videos and then you can work the problems. Number of moles in 1 meter cube of gas at STP. 1 meter cube is 1 liter. NTP, 80 grams of oxygen contains how many atoms? See, this question we will try to understand. 80 grams of oxygen contains how many number of atoms? The question. Now we know that. See, if you don't use the formula also, it's fine. If you can have a little of understanding the subject, you can work. So 32 grams of oxygen contains 6.023 to 10 power 23 oxygen. Not see here, this is confusion. 32 grams of oxygen contains 2 into 6.023 10 power 23 oxygen atom, because 32 grams is 1 mole. So oxygen normally we represent as O2. So therefore, they're talking about atoms. If you get confused with molecules, then it's a problem. So 32 grams of oxygen is containing 2 into 10 2 into 6.023 10 power 23 oxygen. For 80 grams contains how much? 2 into 6.023 into 10 power 23 into 80 divided by 32. That's enough. Okay, we will calculate. Or else, how many atoms? All right, no, we'll go directly like this. 80 grams of oxygen contains as many number of atoms as in. So what we will do is, we will calculate the number of mole. So number of moles of 80 grams of oxygen. So 80 divided by 16 atomic mass atom, So we'll take the 16. So 80 divided by 16 will be equal to 5 moles. 5 moles. So this is what is given. Now we'll calculate. 10 grams, first option, 10 grams of hydrogen is equal to how many moles? So it is 10 divided by 2. This also is 5 moles. So 80 grams of oxygen contains as many atoms as 10 grams of, not 10 grams. This is this also contains 5 moles of H2. So 5 grams of hydrogen. So number of moles in 5 grams of hydrogen. So atomic mass of hydrogen is 1. Since they were given 5 grams, 5 divided by 1, it will be 5. So therefore, the answer for this question is option B. It's confusing. I hope you followed what I was talking about. If you have any clarification, you can ask. Are you people there? Yeah. The next one. Number of molecules in 18 milligrams of water in terms of Avogadro's number. 18 milligrams. So 1 gram is equal to 1000 milligrams. Number of molecules in 18 milligrams of water. So we can say 18 grams of water. 18 grams is how many milligrams? 18 into 10 power 3. Not 18, 10 power 3. It will be 18 divided by 1000. So it will be 18 into 10 power minus 3 milligrams of water contains not Avogadro's number. Maybe we'll the number of molecules 18 milligrams. So we'll write it like this: 18 grams of water contain 6.023 into 10 power 23 water molecules. So 18 milligrams is 18 into 10 power minus 3 grams of water contains. It will be 18 into 10 power minus 3 into 6.023 in 10 power 23 divided by 18. So this will be equal to what? Avogadro's number into 10 power minus 3. So this N stands for Avogadro's number. So the answer for this question is option 1. Are you following? Did you follow this? Nobody is following. So how many times atoms of sulfur is heavier than carbon? All that. Yeah, tell me. Where is that? Any doubt you can ask?
Nothing, sir.
Okay. So how many times an atom of sulfur is heavier than atom of carbon? Find out these kind of questions. This is not working. Cursor is not working. Right. I don't know why. Yeah. Sometimes cursor is also not working. Work out this problem. Now, mole concept, simple problems you can calculate. Calculate the number of molecules present in 342 grams of cane sugar, 1 liter of water, assuming the density of water is 1 gram per centimeter cube, 1 drop of water having mass of 0.05 grams. You can work these simple problems. They've given also in this video. You can check. A lot of problems I have worked. So similar kind of problems here we have. You can clarify if you have any doubts later. Calculate the number of atoms. This kind of question is important. Calculate the number of atoms constituting 53 grams of sodium carbonate. 53 grams of sodium carbonate. What is the molecular mass of sodium carbonate? Molecular mass of sodium carbonate is 23 into 2 plus carbon is 12 plus 16 into 3, 48, and this is 106. 106 grams of sodium carbonate contains what's that? 1 mole. It is 1 mole. So 53 grams of sodium carbonate will be 0.5, half a mole of this. Half the mass we have, therefore it's half a mole. Now they're asking calculate the number of atoms of the constituent element. They're asking you to calculate the atoms. So atoms they're asking. Now you should remember to calculate the number of atoms. So one molecule, see 1 mole, this is half a mole. When we say half a mole, well, I'll write it here only, we'll simplify this. So half a mole means 6.023 into 10 power 23 divided by 2. So it will be 3.015 into 10 power 23. Half a mole is this. This is half a mole. So now one atom, one molecule contains how many atoms you see? 2 sodium atoms, 1 carbon and 3 oxygen. Totally 6 atoms. One molecule contains 6 atoms. So they're asking total number of atoms. So these many number of atoms will contain how much? Because this many number of molecule is there. So it will be 6 into 3.015 into 10 power 23. This is around 18.0 into 10 power 23. The whole total number of molecule will be 18 into 10 power 23. See, they have not mentioned here. They have mentioned for 1 mole, 0.5 mole contains. What's the question? Total number of moles. Here they have calculated only for oxygen. They have calculated only for oxygen. All right. So total number of moles will be this 18 into 10 to the power 23 atoms. All right. We'll continue the class next week. Ma'am? Ma'am,
Yes,
can
sir.
I stop the
Yes,
class,
sir.
ma'am?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.